Okay, next question. A steel pipe, 1.5 inches thick, 30 inches in diameter, and 18 inches in length. So the length of the pipe from, if I was to draw the center line from here to here, is 18 inches. So if I turn 18 inches into feet, I'm going to get 18 divided by 12 inches in a foot. So I'm going to get 1.5 feet. Okay, 18 inches is a foot and a half. 12 inches in a foot, and then another 6. 6 is half a foot. So we have 1.5 feet. And this again is the symbol for a foot. 1 is for a foot, 2 is for inches for those on the metric system or who grew up with the metric system. So that is 18 inches in length, and then the diameter from one side of this opening to the other side of this opening here is 30 inches in diameter, and this is the symbol for diameter. So the diameter is 30 inches, but we don't want to go by the diameter. How I look at these problems when we're calculating the weight of the pipe, we have two ways that we can do it. One of the ways that we can do it is we can say, okay, look, I've got this shape that looks like a cylinder, and I can calculate the total volume of this whole thing, like the whole thing as if it was one big solid block. And then what I can do is I can find the so if this is a pipe, what I can do is then I can do the same thing again, but I'm just finding out what the actual volume of just the inside or the missing void is, and then I subtract this outside part from, or the inside part from the outside part. Now, that's one way to do it, and that's a very accurate way to do it. What I like to do is I like to pretend that I have a knife or some kind of cutting torch or something, and then if I cut that pipe lengthwise, and then I rolled it out flat, like a pipe rolling in reverse, and I steamrolled it and I flattened it out. This distance that goes all the way around here is going to be the same length as if I had a flat plate laid out like this. Okay, so we can take the steel and we can actually kind of lay it out flat. And what that does for us is that, again, it gives us a nice, easy way of calculating it using our original 40-pound kind of standard piece of steel is 1 foot by 1 foot by 1 inch. So if we pretend that we cut this pipe on this seam and then rolled it out flat like this, we have a piece of steel that is 1.5 feet in that direction, and then this length here for our length times width to find the surface area is the circumference. And if you remember back to your math classes in high school, circumference equals pi times the diameter of the pipe. So the pipe diameter is 30 inches times pi. And if I pull up our calculator and I say 3.14 times 30 equals 9. Close that down. That equals 94.2 inches, but that's inches. We want to find out how many feet that is. And so if we pull up the calculator again, I closed it. So we pull up the calculator again. So the way to get inches into feet is to divide it by 12. So if it's 94.2 inches and I divide that by 12, I'm going to get 7.85 feet. Okay, so that's 7.85. I want to multiply it by this 1.5. So I take my 7.85 and I multiply it by 1.5. I get 11.775 square feet. So that's this dimension here of our circumference times 1.5. It gives us 11.75 square feet. So if we have 11.775 square feet, and we multiply that square feet by our 40 pounds per square foot, we get 471 pounds. But in our question here, it says that the pipe is 1.5 inches thick. So this thickness here is 1.5 times the weight per square foot of our 1 by 1 by 1 40-pound steel plate that we've been working on. So we have to take this 471 and we have to multiply it by 1.5. And we get 706.5 pounds. And always put the unit in the end. So again, just to recap, we took the length, which was 18 inches, we turned it into feet, 1.5 feet. Then we found the circumference here in inches, divided it by 12, and figured out how many feet we had. Then we multiplied, which gave us this number here. This was the circumference between, which was our 30 inches times pi. Okay, so that gave us our length, but it gave it to us in inches. So we divided that by 12. Okay, so this was kind of how we calculated that out. Now, if they had said the pipe was 3 feet in diameter, and we were given that in feet, we wouldn't have to convert that by dividing it by 12. We're just dividing it by 12 to find out how many feet we have. So we had the number of feet, I can't remember what it was, and we timed it by 1.15, and that gave us 11.775 square feet. Then we multiplied it by 40. If it was a 1-inch plate, it would be 40 pounds a square foot. Okay, so if these were all square feet, but then we looked at it and said, oh, hold on a second, it's 1.5 inches thick. So we have to take that number that we got by multiplied by 40 and then multiply it by 1.5 again. And the answer was 706.5 pounds. Okay, so again, all we're trying to do is find out how many square feet we have. Okay, and then you take those square feet and then you multiply it until you find the surface area, and then you find the surface area in square feet, and then you multiply it by the thickness in inches of the plate. So if it's a 1/2 inch plate, we multiply it by 0.5. If it's a 1.5 inch plate, you multiply it by 1.5. If it's a 2-inch plate, you multiply it by 2. Okay.